From equation 1, instead of a to the power 1 by 3 plus b to the power 1 by 3, we can write minus c to the power 1 by 3. We have the exponent in the form of a quadratic equation here. So we can make a substitution of some algebraic factor and solve the value for x. A power m into a power n is equal to a power m plus n, the very first law. And the second law is a power m by a power n can be written as a power m minus n. Hello everyone, a warm welcome to one and all. This is Yashruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Here in this session, we will revise the laws of indices and let's take few problems on that. Now, we have learnt the laws of indices. A power m into a power n is equal to a power m plus n, the very first law. And the second law is a power m by a power n can be written as a power m minus n. And the third law states a power m whole power n is equal to a power mn, provided a is any real number and mn are any non-zero positive integer. Simplify x power a divided by x to the power b whole to the power a plus b into x to the power b by x to the power c whole to the power b plus c, x to the power c by x to the power a whole to the power c plus a. Now, using the second law of exponent, we can write this in the form of x power a minus b, and also we have whole to the power a plus b. Now, this again using the second law, x power b minus c whole to the power b plus c. Again this x power c minus a whole to the power c plus a. Now, using the trigonometric identities, a minus b, a plus b can be written as a square minus b square. So, this becomes x to the power a square minus b square. Similarly, this becomes x to the power b square minus c square, and here it becomes c square minus a square in the power. Now, since the base are same, using the first law of indices, we can write this as in the form of x to the power a square minus b square plus b square minus c square plus c square minus a square. Clearly, you can see a square minus b square plus b square minus c square plus c square cancelled. So, the power of x is 0. We also know that anything to power 0 should be consider the value as 1. Hence, the value is 1. Next one, simplify x power a by x power b, a square plus ab plus b square, x power b by x power c to the power b square plus bc plus c square, x power c by x power a to the power c square plus ca plus a square. Again, using the second law of exponent, we can write this as x to the power a minus b whole to the power a square plus ab plus b square. And here again, x to the power b minus c whole to the power b square plus bc plus c square. And again here, x to the power c minus a whole to the power c square plus ca plus a square. So, we know that a cube minus b cube can be written as a minus b, a square plus ab plus b square. Similarly, using the same concept here, b cube minus c cube can be written as b minus c, b square plus bc plus c square, and c cube minus a cube can be written as c square plus ca plus a square into c minus a. So, using this trigonometric identity here, this becomes x to the power a cube minus b cube into x to the power b cube minus c cube into x to the power c cube minus a cube. Now, since the base is same, the powers can be added. So, x to the power a cube minus b cube plus b cube minus c cube plus c cube minus a cube. So, powers with opposite signs get cancelled. So, we are left with here x to the power 0. This is equal to 1. Next question. If p power x plus q power y is equal to r power z, s power w and pq is equal to r, that prove the given condition. So, now let us assume that p power x is equal to some k. So, let all of this is equal to some k. Also, q power y is equal to k, r power z is equal to k, and s power w is equal to k. So, shifting the power to the right hand side, we'll get p is equal to k to the power 1 by x, q is equal to k to the power 1 by y, r is equal to k to the power 1 by z, and s is equal to k to the power 1 by w. Now the condition is given here, pq is equal to r into s. So here k to the power 1 by x into k to the power 1 by y equals k to the power 1 by z into k to the power 1 by w. Now here base is same, so powers can be added. K to the power 1 by x plus 1 by y is equal to k to the power 1 by z plus 1 by w. So now since base are equals, power can be equated. So 1 by x plus 1 by y is equal to 1 by z plus 1 by w. Next question. If a, b, c is equal to 1, then prove that 1 divided by 1 over a plus b inverse plus 1 divided by 1 plus a plus c inverse plus 1 divided by 1 plus c plus a inverse, that is a to the power minus 1 is equal to 1. Now here consider the left hand part. So we have LHS, so as 1 divided by 1 plus a plus b to the power minus 1 plus, so b plus c to the power minus 1, 1 plus c plus a to the power minus 1. Since a, b, c is equal to 1, we need to apply the condition here. So we also know that a to the power minus m is equal to 1 divided by a to the power m using the laws of exponents. So here I can write this as 1 divided by 1 plus a plus 1 divided by b. And here we have 1 plus b, 1 by c. And here we have 1 plus c, 1 by a. Now here I'll multiply b, 1 divided by b plus ab plus 1 whole divided by b. And here we have c plus bc plus 1 whole divided by c. And here we have 1 by a plus ac plus 1 whole divided by a. So I can shift a, b, c to the numerator. Then this becomes b divided by b plus ab plus 1 plus c divided by c plus bc plus 1 plus a divided by a plus ac plus 1. Now since a, b, c is equal to 1, instead of 1 here, I'll replace it by a, b, c. And here we have ac. Since a, b, c is equal to 1, I can write ac is equal to 1 by b. So instead of this, I'll write 1 by b. So after substituting this, we'll get the value b divided by b plus ab plus 1 plus c divided by, here c plus bc plus abc, c plus bc plus abc plus, here in this term a divided by a plus 1 by b plus 1. So a divided by a plus 1 by b plus 1. So now we can write this as b divided by b plus ab plus 1. You can see c is the common factor in numerator and denominator. So we have c 1 plus b plus ab plus here a divided by ab plus 1 plus b whole divided by b. We can cancel c here and we can multiply b to the numerator. So we are left with b divided by b plus ab plus 1, 1 divided by 1 plus b plus ab, ab divided by ab plus 1 plus b. In all the three terms, we have a common denominator 1 plus b plus ab. So we can add the numerator directly, b plus 1 plus ab. So denominator can also be written as b plus 1 plus ab. So same value in the numerator and denominator gets cancelled. The value is 1. So that is equal to the right hand side. Next question. If a to the power 1 by 3 plus b to the power 1 by 3 plus c to the power 1 by 3 is equal to 0, then show that a plus b plus c whole cube is equal to 27abc. So now here from the given condition, a to the power 1 by 3 plus b to the power 1 by 3 can be written as minus c to the power 1 by 3. Consider it as equation 1. Now let's cube on both sides. Then a to the power 1 by 3 plus b to the power 1 by 3 whole cube is equal to minus c to the power 1 by 3 whole cube. So using the laws of exponent, if we have a to the power m whole power n, then I can multiply m and n. When we multiply 3 into 1 by 3, it gets cancelled. So we are left with minus c on the right hand side. Now here we can use a plus b whole cube formula. So which can be written as a cube. That is, this is a now, a cube plus b cube plus 3ab. So that is 3ab into a plus b. That is a to the power 1 by 3 plus b to the power 1 by 3 is equal to minus c. Now from equation 1, instead of a to the power 1 by 3 plus b to the power 1 by 3, we can write minus c to the power 1 by 3. So here 3 get cancels, 3 get cancels, a plus b plus 3 a to the power 1 by 3, b to the power 1 by 3 is minus c to the power 1 by 3 is equal to minus c. Now multiplying minus here and shifting c here and this term towards the right hand side, we get a plus b plus c is equal to 3 a to the power 1 by 3, b to the power 1 by 3, c to the power 1 by 3. Now cubing on both sides, a plus b plus c whole cube is equal to 3 a to the power 1 by 3 into b to the power 1 by 3 into c to the power 1 by 3 whole cube. So it's a common power to all the terms here. That means we need to cube all the 4 terms here. So now here a plus b plus c whole cube is equal to 3 cube is 27. A to the power 1 by 3 into 3 is a. B to the power 1 by 3 into 3 is b. C to the power 1 by 3 into 3 is c. So therefore a plus b plus c whole cube is equal to 27abc. Next. Solve 2 to the power 2x minus 6 into 2 power x plus 8 is equal to 0. So we have the exponent in the form of a quadratic equation here. So we can make a substitution of some algebraic factor and solve the value for x. Now here let me take 2 power x is equal to some a. Now when I square on both sides, 2 power 2x can be written as a square. Now substitute here, then we will get a square minus 6a plus 8 is equal to 0. Now this is in the form of a quadratic equation. We can use the formula method or the factorization method. I'll use the factorization method. I'll split this into 2 linear factors. So 6 can be written as 4 minus 2. Minus 4 minus 2 is minus 6. Minus 4 into minus 2 is 8 is equal to 0. So taking a common here, I'll get a minus 4. Taking minus 2 common here, I'll get here a minus 4 is equal to 0. Again taking a minus 4 as a common factor, I'll get a minus 2 as a factor. Now from this observation, we can write a is equal to 4 or a is equal to 2 forms the solution for a. But I need the solution for x. So what is a? Have taken a in the form of 2 power x. So therefore here 2 power x is equal to 4, 2 power x is equal to 2. So instead of a is equal to 4, I have taken 2 power x is equal to 4 and 2 power x is equal to 2. Now to make the base same, I'll write this as 2 square. Now since base are same, the powers are equal. So therefore here the value of x is 2. And here also 2 power x can be written as 2 power 1. So base are equals. So therefore I can equate the power. So x is equal to 1. So therefore the value of x is x is equal to 2 or x is equal to 1. So in this session, we have found many applications of using laws of indices or laws of exponents while solving certain problems. I'll meet you in the next session with the new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.